We're going to talk about marginals and differentials in this section. The learning objectives are to find marginal cost, revenue, and profit, find delta y and dy, and lastly, use differentials for approximations. So today we'll do things like how do we, let's say, approximate what square root of 11 is without having a scientific calculator. Okay, so that will be one of the problems that we will do. So recall that this difference quotient formula we worked with. And the derivative was when h was approaching 0, right? The distance between 2 points. As that approaches 0, we have a single point. So we were using this to define derivative in chapter 1. So this represents the slope of a secant line. See, secant line, what I mean by that is, let's say that we have 2 points. Let's say that we have a point right here. And we have a point right there. So if the first point is x and f of x, and the second point, let's say the distance between them is h, then I will have x plus h for its x value, and the y value will be f of x plus h, right? So if you do the slope formula, remember y2 minus y1, so this minus f of x, so that's what you see on top of the fraction, over x2 minus x1. See, if you subtract x plus h minus x, you will just have h there. So this is really just slope formula. So we start with a slope of a secant line. So the slope of this red line is this formula. And when we define derivative, we said we're going to make this distance h, and h refers to the distance between these 2 points. We're going to make them infinitely close so that their distance is really 0, and that's how we really defined the derivative, right? Or slope of a tangent line. The number h is regarded as the change in x, right? As x goes from this first point to that second point, okay? H was the distance. It was the change in x value. Another notation for such change is draw a triangle. We read this as delta x. And delta refers to the change in x, okay? So for f, a continuous differentiable function, a small delta x, you can define, the approximation will be f prime of x. The derivative at x is approximately change over y over change of x, okay? So look, I can multiply both sides by delta x. Look what will happen if I multiply both sides by delta x, which by the way is also, I'm going to write this as dx, but if I multiply this derivative, okay, which is change over y, change in y over change in x, the delta x cancels out, and what's left? Delta y is left, right? The triangle y, delta y, so this is left, and that is approximately equal to what's sitting on the other side of this equal sign, this thing right here, okay? If you write f prime of x first, and look, instead of triangle x, instead of delta x, I'm going to write down dx, okay? And that's how we have this formula for delta y. We're going to find delta y, okay, by finding the derivative at x and multiplying by change in x, okay? So let's look at this definition. Let's fill out some definitions, or actually read it, okay? So for y equals f of x, for our function, we defined dx, and we call this the differential of x by delta x, and dy called the differential of y by dy, and there's that formula that we just kind of derived, and this is just from looking at the slope of a tangent line is a change in y over change in x. Okay, so we're kind of, nothing much right now, but we will do some problems involving these changes in x and changes in y. But very, building on to what we kind of already talked about in chapter 1. Okay, so that's what we're doing in this section. Okay.